So I'm going to skip because I think I can do this in 20 minutes so that I will not rush next class to do. This is actually not in the chapters, but this is what I want. Somebody asked this question about mixing some produced water with some other water, fracking water, or in this case, it will be an example that I am mixing I will be mixing the Olympus brine with seawater, okay? And I will show you how to do that. Actually, this says it's for another well, but it's the same step, so we can just go ahead and do this. So what we will learn is how to use the water mixing with the water mixing tool in the OLI software. I also see a question, and I'm going to address this question first. It says, in the Olympus production stream, the option for drop solids at different locations means not to include solids. Okay, so let me just really quickly go there and ask for Olympus production. So just to answer this question quickly, you have this option of drop solids here under conditions. That means that, let's say, from reservoir and bottom hole, you know that you're precipitating some solids. Maybe it's a fast-forming solid, like halite, okay? So you can say, okay, drop the solids at that location. But that means that the solids that were precipitated out are going to change the chemistry of your brine, right? Because you're precipitating those solids. So you have probably less chlorides, less sodium ions. So for the next calculation from bottom hole to down hole, this bottom hole calculation will use the new chemistry, the one that has less chlorides and less sodium, because you already removed those solids from the chemistry. So only what is left in the solution will be used for the next calculations, okay? When you don't put drop solids, you're basically saying that the solids are flowing from reservoir up to the separator, okay? I hope I answered that question. Okay, so now what we are going to do is we are going to learn how to use the mixing tool. So let's go to the actions pane and add a mixing water, okay? So double click on mixing water and maybe just let's not change the name. In here we can just simply say mixing water. And now to the right, you will see a different window here, where in here you will need to define the brines that you want to mix, okay? So what happens with this tool is that in here, we designed it to mix brines. But let's say you also want to know, or you want to add the gas, and you also want to add the oil. You could do that, but the default is mix the brine from the production brine and a second brine, probably from another production, or maybe seawater or any other water that you have the water analysis. If you want to account for the gas and for the oil, you manually need to enter that information here. So you will need to come here in the drop-down arrow and say, okay, you have an oil, you have a gas, okay? But for the demonstration purposes here, I'm going to just use two brines that I'm going to mix and study the incompatibility of these two brines, okay? So the first thing I want you to do is we are going to use seawater to inject or to mix this the seawater with the produced water of this Olympus brine that we have produced in this Olympus gas well. So in the software, we have what we call objects, that let's say you always use the same objects for all your calculations. And you have the option to save those objects. So at the moment you don't see them because we don't put them by default. But what we can do is go to View, okay? Then we go to Toolbars, and it's the only one that is not selected, Object Library, okay? And this object library has very many, well, not a lot, but some standard objects. You have pseudo components, basic produced water analysis. It has a standard seawater analysis, seawater, etc. I want to use this seawater here. That is a standard object. You can always add objects in my objects. If you always use the same water analysis, you can just put it here. But at the moment we are going to use the standard objects. For this seawater, select this one that says is in the beaker. The other ones are probably streams. The one that I'm interested is in this beaker. And I'm going to select it and drag it to the navigator panel. Okay. When we created this seawater analysis, we created it in the AQ framework. So in this case, it's the only case that we need to change and make sure that the framework that we are using here is the MSC SRK. So select the seawater and go to the Tools bar and select MSC SRK. So we have changed here the thermodynamic framework of the specific seawater. Okay. The next step that we need to do is to go to the reconcile. We need to calculate the properties of the seawater. We go to the reconcile and go ahead and calculate. Now, the software is giving you here, this is simply a warning, and it's telling you that these two components, they have not been regressed for the MSC SRK, but it's okay. I don't think that this will give very many errors for our demonstration today. Okay, so the same story as before. The brine is super saturated and it may precipitate out two solids. Okay, so we have now two brines that we want to mix, the Olympus brine and the seawater. Okay, now the next step is to define those two brine analysis in the mixing tool. So we go back to the mixing tool or the mixing water here. And so in this mixing water, we will need to ask ourselves several questions. Where are we mixing these waters? Okay, are we mixing them at the reservoir, at the perforations? Are these mixing is in contact with some oil, or all of these things we need to know what's happening at the mixing, okay? Once we know what the phase contacts are going to be, then we can enter the information here in the software. So for these examples, we are going to seawater breakthrough, and basically that we're going to mix seawater and we are going to mix the Olympus brine. Now, the other thing is that we need to define, okay, where are we mixing? So in here is where we are going to enter the conditions. These conditions and the mixing conditions that I have for this example are, let me just change these units. Apparently, I did not change the units in my example, but the mixing conditions are at 200 Fahrenheit and 147 bar G. Okay, so what we do is simply click on this temperature here in the hyperlink, okay, and change the temperature to Fahrenheit, and then change the pressure to bar G. Okay. So the temperature the mixing temperature here is going to be 200, and the pressure is going to be 147. Okay, So those are the conditions. For the first brine, we're going to define that is the Olympus brine, okay? And we're going to say that we are producing this brine at 200 cubic meters per day. And the second brine will be the seawater. Okay. Now, I want you to notice something about this tool, this mixing tool, and is that in here, the only flow that we can define is for the first brine, okay? And really is the total volume. So even if it looks like it is only for the first brine, this 200 cubic meters per day is for the mixture. And the seawater, so in this case, I am saying here in this specific definition is that I have 200 cubic meters per day of Olympus brine and 0 of seawater, okay? So how do I fix this? How do I make sure that I change, let's say, 180 cubic meters per day of Olympus brine and 20 cubic meters per day of seawater? So what we will do next is to go to the Conditions tab, okay? And in this Conditions tab is where we need to select the type of ratio or the type of how much inflow we want to get from mix, you know, like from Olympus brine or seawater. So this is what I was saying. When I enter 200, the software immediately assumed that the second brine will be 0. And by default, the software creates 5 different steps. So the first step is 200 cubic meters per day. The second one is 0. The next one is 160 and 40. If you want to increase the resolution of these ratios or these flows, you can simply come here where it says steps and enter 10 and then click on auto step, and it immediately recalculates the steps for you. So every single point here, it will combine 100 cubic meters per day, 180 cubic meters per day, and 20, 140, 140, and 60, and etc. You get the idea here. The next step is the solid step. And in here, we simply select standard, and we can go ahead and calculate. So we are mixing 2 brines. And what we want to know is the incompatibility. When you mix these waters, what is the worst case scenario, or which is the ratio that will give you the worst case scenario when you are mixing these two brines? Okay, so the software, as usual, will plot here the dominant prescaling tendencies, and it will tell you which solid will be potentially forming when you have this mixing, when you mix these 2 waters, these 2 brines. Okay, so it's doing 50. Now we have, okay, so how do we interpret this plot here? So down here, we have the Olympus brine ratio, okay? This means that down here, we have 0 cubic meters per day of Olympus brine ratio. And at 1, we have 200 cubic meters per day of that Olympus brine ratio, okay? At this 0 here, so then we have 100 seawater, 200 cubic meters of seawater. So it will be 0, 100, and then for the ratio, and then here will be 100 of Olympus brine and 0 for the seawater. And the software in here is going to calculate again the 5 dominant prescaling tendencies. In here, I think that this is actually not accurate. Here is saying that you will form this the solid here, which is the magnesium silica oxide in here. So for some reason, I don't know why we did not select that as a standard scaling. And that is obviously, look at the rescaling tendency of that. So I will just remove this for demonstration purposes. I'm just going to right click and remove it. Right click, hide. Okay. I need to find out why it's predicting that specific solid there. And in here, now you'll see the different, what happens, what are the prescaling tendency values as you mix these two brines. You see that there is, this is an incompatibility plot here. You have a maximum point, and that maximum point is happening for barite, a solid prescaling tendency of around 7. Yes, around 7. And it's telling you that this ratio at 30% or at 0.3, so that will mean 30 cubic meters, let's say 30 cubic meters of the Olympus brine ratio, and 70 of the seawater will give you the highest precipitation of barite at this condition. And notice that for the other solids, let's say calcite in here, no matter, actually, if you have 100% Olympus brine, you have the highest calcite precipitation. If you don't have Olympus brine, if you just have the seawater, then you will have less precipitation of calcite. Okay, so at this point, it seems that the solid that is going to have maximum precipitation here, or the ratio where you're going to have a maximum precipitation of barite is this 0.3 ratio. Okay, and again, you can always study. In this case, you can go and see what were the solids that actually formed. And for this example, we have that the two solids that formed was calcite and barite. And in here, it will tell you how much of each solid at the different ratios of these scales were formed. Okay. Are there any questions about this? Probably I went too fast just because of the time, but I just want to show you how to use this mixing tool. I know that there were people asking for it, and I just want to show you how you can enter the information and how you can analyze the results.
Can you show me again in the plot how you removed the magnesium scale? Because I don't seem to get the same thing on my right click.
Yeah, I removed it, and I don't understand why the magnesium is there, because I did not select it as one of the potential solids. See, these are the standard solids that I was expecting to see. So when I went to the plot, I right-clicked on that specific magnesium plot in the magnesium line, and then I said hide.
Hide legend.
No, it's only hide here.
So what did you click on to get to hide?
Oh, so you select any point of that line, any point, and right-click on any point, and then select the option hide.
It doesn't. I'm getting options and select data, but is it in plot options?
No. Close the options, and let's say I'm going to do it with this barite down here, even though it's solids. So right click on this data point.
Yeah, I don't get that window. I just get options. Let me try again.
Let me see options. So let me see.
No, it's okay.
Yeah. I've got it. Getting options like this, right?
You've got to click on one of the plot points, not the line. Sorry.
Yeah. So if you get options, so right click options, then plot options. Let's see if I can do it from there. Yeah. So you go to curves. It's just much more difficult, but and in here you'll see the magnesium silicate oxide, and I just selected hidden. I could put it back. Let me see. See, it's here.
Yeah.
So I go to this point here,
Yeah.
right click on it and select hide,
Thank
and
you.
it will go away. Yes, so the beauty of these mixing ratios is because now you know what's the worst ratio that will cause you the most scaling risk when you're mixing these two waters. Okay, so with this, I will stop here, and next class we can continue with another example where I will show you how to create facilities and the oil analysis.